Under pyramid 1, we will proceed to solve a problem 1. The problem goes like this. A square pyramid, 35 mm sides of base and 65 mm axis length, rests on HP on one of its edges of the base, which is inclined to VP at 30 degrees. Draw the projection of the pyramid when the axis is inclined to HP at 45 degrees. The problem clearly says it is a square pyramid of 35 mm sides, whereas the axis height is given as 65 mm axis height or axis length. Please find out clearly, it is resting on the side, not on the corner. The square pyramid is resting on one of the base edges, not one of the base corners. It also says the base edge, which is inclined to VP at 30 degrees. Draw the projection of the pyramid when the axis is inclined to HP at 45 degrees. The axis inclined, this is a triangle, true inclination. The axis inclined to HP at 45 degrees is a triangle. You should make the true inclination first step and you have to make the apparent inclination second step. The answer is very simple. First I will draw the square pyramid top view and the front view, because the inclination to HP is at an angle of 45 degrees. So I'll keep the pyramid in this manner, draw the top view, front view, make it 45 degrees to HP, then make it inclined to VP. I'll go with initial figure, right hand side it should be perpendicular here, then make it 45 degrees HP, draw the top and front view, make the standing side inclined to VP, draw the front view and top view. One principle I would like to inform here. When it is inclined, when you want to draw the new top view, the apex is nearer to you than the base. In the new top view, base is not fully seen, only outer boundary is seen. When you make the last figure, the standing side inclined to VP. In the front view, base is nearer to you, apex is away. In the front view, base is fully seen. I'm going to give you small instruction how to complete the entire figure, how to draw the triangle, visible, triangle, not visible, how to draw the full line, dot line. A simple procedure I'll explain to you, you'll follow this. The initial figure, square pyramid 35 mm side. Draw here 35 square pyramid. Draw here 35 mm square pyramid. Slant edges, draw the slant edges. There's the slant edges. We have the center. You can locate your apex point O, bottom O1. Let me make on the four corners as A, B, C, D. Right hand side I have taken the straight, perpendicular XY line. Let me dimension them. This is 35 mm square. This is 35 mm square. Let me dimension this. This is square of 35 mm. Top is ready. Project and draw the front view. Project and draw the front view. Draw the projectors. Draw the projectors from all the corners and draw the projectors from apex, the axis line. Axis line. The square pyramid is 35 mm base and the axis is 60. From here you measure 65 mm. Look at the point O dash. Base. The entire base is on HP. On the HP, you will find here B and A. They happen to coincide here. B dash and then A dash. Then we have C and D. They happen to coincide. C dash and then D dash. OA, OB, OC, OD. The slant edges. They happen to again overlap one over the other. OC, OD overlaps and then OA, OB. They happen to coincide. We have the axis long and short, the axis. Top view, front is ready. Square pyramid, right hand side I have drawn a line here. We are going to stand on the side. Top view, front is ready as per the dimensions. This measurement height, the height is given as 65 mm height. You can locate here, dimension them clearly. That is 65 mm height. Now, the axis inclined HP at 45 degrees. The axis triangle. So, this axis is inclined HP at an angle of 45 degrees. Since the base, this is O1 dash, the base and the axis, they are perpendicular to each other. Do not draw the axis first. Draw the base first. Then draw the axis, it will come to be given angle. Since it is 45 degrees, 90 minus 45 is 45. you draw the base, measure this length and draw here 45, draw at an angle of 45 degrees. Measure the length of the base here, that is 35 millimeter, draw here, then locate the midpoint, From here, draw the perpendicular, which is, take the height 65 mm, measure here 65 mm height. This 65 mm height, you measure here 65 mm height, this is perpendicular. 90 minus 45, already taken this 45, automatically axis will come as 45. This we have a C dash and then D dash. Here you will have a B dash as well as A dash, Draw the triangle, draw the front view, complete the front view with the slant edges, complete the front view. You'll find now this axis is at an angle of 45 degrees. For example, if you want the axis to be 30 degrees, then you draw the base of 60 degree angle. It will come automatically 30 degrees. If you want the axis to be, for example, 40 degrees, then you draw here the base is 50 degrees. 90 minus 45, 0. 50 degrees. When you draw the perpendicular, automatically get the required angle. This point is O dash, apex point. Now project and draw. How does it appear that when the position of the front view is changed, how does it appear in the top view? Draw the projectors of the base. Since the square base is inclined, it will appear like a rectangle in the top view, similar to lamina. Draw the projectors, draw the locus lines from the previous top view, locate the points of the base. A and A, they meet here, that is A, we have here B, C, D and then O. Now how to complete the top view now? A, B, C, D, O, everybody can locate them. How to complete the top view? When you look in the top view, first you come across O, A, O, B. Keep moving down, then you come across O, C, O, D. We have infinite number of visual rays. Project the front view to get the top view. In this view, when you look for the top view, apex is nearer to look arrow and base is away. Make one conclusion, base is not fully seen, only outer boundary seen. I repeat once again, depending upon the look arrow, whether front view or the top view, look arrow, apex is nearer, base is away, base is not fully visible, only outer boundary is visible. Now, first what you come across is OA and then OB. OA, OB. Keep moving down, you come across OC, OD. OC and then OD. Same order, you draw the slant edges here. First one OA, OB. Draw here, OA visible, then OB visible, then outer boundary visible. Next is OC, OD. OC happens to be outside the previous triangle. OD happens to be outside the previous triangle. Hence, it is visible. OC visible, OD visible, accordingly outer boundary visible. You can question me, sir, what will happen if OC, instead of outside the triangle, if the C point was inside, what to do? Then you have to make a dotted line. So as the triangle goes out and out, make a full line. When they go inside, make a dotted line. Let us look at the base. A, B, B, C, C, D. CD is going in 1, 2, 3 triangles. The standing side CD is not visible. It should be a dotted line. Project from here, which is nothing but O1 dash. Project the center of the base. At this point, you can locate here. That is O1. Draw the axis, long and short is the axis. So here we had done initial position, the first step, where the pyramid is standing on the side, not on the corner. Standing side is CD. Axis inclined HP 45 degrees. I draw on the project, the front view, I draw on the new top view. Now what you see, you can easily make out, it is resting on the side CD. O dash is above HP, CD is on HP. Redraw the apparent triangle here, apparent top view here. Such that the CD side is 30 degrees to VP. That you can do rightward or leftward. Easy method to redraw is, this is the rectangle. We have done in lamina how to transfer the rectangle dimension. Measure this. Draw here 30-degree line. Draw here a 30-degree line. Take out the measurement of this rectangle. Take out the measurement of this rectangle. That AB. Draw here perpendicular. Measure AB. Mark here AB. Draw the measurement. Rectangle is ready. Locate the center. Draw the center line. Perpendicular. Draw the center line. So I reproduce the rectangle here. D for me. This center you can locate here, which is nothing but O1. Measure O1O. Mark here O1O. So that's an axis. Complete the figure. That is reproducing the apparent top view such that the standing side is inclined at an angle of 30 degrees to BP. Standing side is inclined at an angle of 30 degrees to BP. I'll show you very clearly. That's an axis, long and short is an axis. I have the corners here, A, B, C, D as the corners. I'll clearly show you. This I have drawn 30 degree, this angle is a 30 degree angle. That is a 30 degree angle. Clearly shows that the CD is at an angle of 30 degrees. Now project and draw the final figure. Draw the projectors. Draw the projectors from all the corners. Draw the projectors from all the corners. Draw the projectors in this manner. Draw the locus lines from the previous front view. You find O and O, they intersect here, that is O dash. A and B. A here, you get a point here, A dash. Then B, you get a point here, that is B dash. C, I can locate here C dash. D, and locate here D dash. This is D dash. So A, B, C, D. When you look in the front view, you find the base is nearer than apex. Base is fully seen. Here apex was nearer, base is not fully seen. Depending upon the look arrow, whether top view look or the front view look. Base is nearer than the apex, base is fully seen. You make A, B, C, D fully visible. A, B, C, D fully visible, absolutely fully visible. Then how to complete the slant edges, visible or not visible? Simple procedure like this. When you look in the front view in this manner, first you come across OC, next is OB, next is OA, last is OD, towards XY. I'm telling you towards XY. So first what you see is OC, next is OB, next is OA, next is OD. Same order you draw here the triangle. If the triangle move out and out, make a full line. If the triangle formation move inside, you make a dotted line. Let me see now. First one is OC. OC first visible. Next is OB. Second one is OB. I already have a triangle now. Please remember, if any line goes inside this triangle, you must draw a dotted line. If any line goes outside the triangle, you must draw a full line. OC over, OB over. Next is OA. Where is OA? OA is outside the triangle. I am drawing a full line. The last one, OD. OD is inside the triangle. It should be a dotted line. OD is not visible. It should be a dotted line. We can project here from the center, the O1. You can project the O1. Get here from the O1 here, O1. Locate the center. That is O1. Draw the axis, long and short, long and short, long and short. Normally, I recommend the axis should be drawn at the end. The entire figure looks neat and clean. Neat and clean. If any line that overlaps with the axis, you can avoid. When the path is clear, show the axis compulsorily. All the figures, the axis must be shown compulsorily from beginning to end. Unless something overlaps, like dotted line, full line overlaps, then you can avoid the axis line. A simpler procedure has shown to you how to draw when the front view positions change, how to draw the new top view, when the top view positions change according to given angle, how to draw the new front view. These are the projections of a pyramid. What I have drawn here, top view here, the front view is here, again new top is here, the front is here, again the new top is here, the front is here. So this is the final answer for the present problem, wherein square pyramid standing on one of the sides, axis inclined HP 45 degrees, the standing side inclined VP 30 degrees. The wordings must be looked very clearly. It says very clearly which is inclined VP 30 degrees. It is standing side, edge means side, which is inclined VP 30 degrees, and the pyramid, the axis inclined 45 degrees. So according to this problem, the data, the answer is this, which clearly indicates the problem answer is shown with change of position method. True inclination first, and then this is the apparent length of the axis, the apparent inclination is the second step. This is the final answer for the present problem.